So today we're going to talk about section 3.2. Section 3.2, the title says, What's Unusual, the Empirical Rule, and Z-Scores. So we're going to be focusing on kind of two main topics here. We're going to be talking about our empirical rule. We're going to be talking about Z-scores. And through our conversation of both, we are going to be bringing up and talking about the idea of what we mean by unusual in the context of statistics. So to start with, in this section, we're going to start with the empirical rule. So the empirical rule is a rough guideline for the approximate percentage of data within 1 to 3 standard deviations of the mean. So our mean that we talked about in the last section, our standard deviation that we talked about in the last section, we're still going to use in this section. Thinking about symmetric unimodal data sets, we're also going to be focusing on these in this section as well, which we'll be able to see looking at the pictures at the bottom of this page. So the empirical rule says that if the distribution is unimodal and symmetric, the two key criteria that I just mentioned, then approximately 68% of the observations will be within 1 standard deviation of the mean. So remember in the last section we said that most of our observations are within 1 standard deviation of the mean, most being about 2/3. Well, 68% is just a tiny bit more than 2/3, so we're still sticking with this idea. Most of our data, but now we're going to give it a more numeric value, 68% of the observations will be within 1 standard deviation of the mean. Approximately 95% of the observations will be within 2 standard deviations of the mean. And nearly all, 99.7% of the data will be within 3 standard deviations of the mean. So again, we're going to continue to use our mean and our standard deviation for our unimodal symmetric distributions. Right? And we're going to, again, just kind of expand on what we did in the last section a little bit more. Right? We generally consider values to be unusual. Right? So this is the other thing that we said we're going to talk about as we're going through our empirical rule and our z-score. We generally consider values to be unusual if they are further than 2 standard deviations from the mean. So let's look at this in a couple of pictures. All right, so let's focus on this top picture here. So this image shows our percentages, and it shows it going out in our standard deviations. So notice our mean is in the middle. And then if we go to the left and to the right just a little bit, we have our mean minus 1 standard deviation, so minus 1s and plus 1s. And in between this 1 standard deviation, notice that we have 68%. Right, so then we go out a little bit further. So now we're between 2 standard deviations. Between 2 standard deviations, we are now at 95%. And then finally, within 3, we are 99.7%. Notice that most of our curve falls in that range. Anything outside of the 2, so anything that lands in either this little tiny tail here or this little tiny tail over here, that would be a value that we would consider unusual. So anything that lies outside of that 95% range would be something that we would consider unusual. The image below this does have kind of another way of breaking down and looking at the percentages. So we still see our 68%, 95%, 99.7%. Notice that also at the mean we're marked 50% below, 50% above. And notice that instead of having just broken down into 68, 95, 99.7, we have it broken down into percentages for each individual region. So 34% to the left of our mean, 34% to the right of our mean, total that's our 68%. Right? And then as we go from our 68% to our 95%, we're adding 27%. Well, 13.5% of that is over here, 13.5% is over here. And then our little tails, again, these are unusual regions. They have a little bit less than 2.5%. They have that 2.35% because we're not quite at 100% there. So as you're going through and you're working through these problems, using these pictures is definitely going to be, referring back to these, is definitely going to be something that you are going to want to do. And it's also going to be something that we're going to use, again, as we continue to move forward in these different problems.